I was doing my PhD in classical general relativity, and the book by Abai Ashtekar fell in my hands. I was in Argentina at the time. There was not much information. There was no internet yet. So I got that book, and I started reading it, and it looked cool and interesting and promising what they were doing. And that led me to apply for a postdoctoral position with them in their group in Syracuse, and that's how I came to the U.S. to work with them on quantum gravity. I was one of the first to work on loop quantum gravity as a consequence in the late 1980s, and that's how I got into the subject.
Great. And a bit more specifically, maybe you can talk about some of the challenges that make it so difficult to unify these two theories. Perhaps speak towards, I'll just be a bit more specific before you answer, how background independence and relational space and time, which come from general relativity, are kind of fundamentally opposed to background dependence and absolute space and time in quantum mechanics. What kind of a role does that play in making it so hard to reconcile these two theories?
Yeah, all our theories of physics, electromagnetism, mechanics, and then the theories of particle physics are all theories that are formulated on a background fixed space-time. Space-time plays no role. It's just there in the background, fixed once and forever. General relativity, which is a theory of gravity, changes that. Gravity is described as not as a force, but as a deformation of space-time itself. So it's completely different from the other theories. Quantum mechanics was developed largely to deal with the other theories of physics. It wasn't developed to deal with gravity. And some of its fundamental sort of basic principles are a little bit at odds with gravity. I mean, for instance, quantum mechanics is probabilistic, meaning you have a probability of something happening, presumably in the future, which leads you to talk about a given time. Whereas in general relativity, space and time are unified, and you can choose any time you like. And in essence, that is possibly at the root of all the problems, that to make the arena where physics takes place, which is space-time, into a probabilistic concept is something that is making our heads explode, essentially, in various different ways. I mean, this is the easiest way of putting it, but if you forget that and you just work the math rebels itself. It gives you problems that reflect this basic problem we're talking about.